Hi guys, let's now look at the second sort of like examples in our inequalities. We have 4x squared minus 4x plus 1, and if you look at that, you can sort of like see from great practice of completing a square that this is a perfect square. Right, so go ahead and factorize that. When you factorize that, that's what you get. And yeah, so that's what you get. And when you that's what you get. So when you're trying to find the critical values, you have to take that 2x minus 1, set it equal to 0, the first one, take the second one, get it equal to 0. So you're basically gonna get x is equal to 1 over 2 by 2, right? You're gonna get two solutions where x is equal to a half 1 over 2, right? Let me see what they're saying here. From the factorized quadratic, we see that the value for which the inequality is equal to 0 is x equal to 1 over 2. Just want you guys to note that there will be two of those, x is equal to 1 over 2. One coming from this bracket, the other one coming from that bracket. That's very, very important. We know that a squared is equal to 0. It's greater than 0 all the time. So if you take a value and you square it, it's always going to be greater than 0. That's what they're trying to say here. For any real number a, where a is not equal to 0, so then that 2x minus 1 squared will never be negative, right? So that will never be negative. And if you look at what the question is asking, it's asking where is it negative? Where is that function less or equal to 0, right? So let's see. Our sketch approach or graph approach. Identify, you look at your a is greater than 0. Look at your roots are 2, so they are both 2 halves falling exactly at that point. Then when you just try to draw that, that's what you get, right? Don't have to be accurate about anything else that happens outside. If you're trying to think about where exactly does it intersect here, don't worry about that. That doesn't matter even if you drew it wrongly. But basically that would be your y-intercept, right? Your plus 1 over there, that's your y-intercept. But we're going to look at that when you're drawing graphs. That's what we're doing. And you can see that's why I prefer this than the algebraically, because you can really see what's happening. So you can see that there's no part of the graph that lies below the x-axis. It's on the x-axis or it's above, right? So really, when they ask where is this function less than or equal to 0, where is this function less than 0 or equal to 0, there's really no point, right? So but what I want you to notice is that at x is equal to a half, our function is equal to 0, right? So our final solution would actually say that for this function f of x squared minus 4x plus 1 less or equal to 0, there's no point where it's less than 0, but at x is equal to a half, our function is equal to 0. So that's really going to be your solution, right? You're going to be giving a solution for where you are looking at the function. Your solution would be where that business over there is equal to 0, which is really over there, which is your solution. Guys, I urge you all the time to contact me if you're struggling with what's happening here, because as I am teaching this, I can't get a sense of whether you understand or not. And these are really, really, really important ideas. They are super important. If you're struggling with this, you need to talk to me. Let's move on to our second, or perhaps let me make a new video on the next example.